So this week we're going to talk about the final electronics projects. Ashley and I went through a lot of different projects to try and find some that would be accessible for a lot of different skill levels. So we came up with several options. We'll look at each one of those.
Is your mic on?
It is.
Okay.
I can hear.
You know, I assume you can hear me. So this is like my quick overview. We have some simpler and more challenging options that are for both no code and with code. So the first one is the stick person. So it's a human-sized stick person costume, and basically you just take these light up tubes and you combine them together, and then you can wire them up to like a battery pack and sew them to articles of clothing and run around doing whatever you want to do as a stick person. So, you know, not too bad. I also tried to price out the costs for each one of these a little bit. So, you know, based on the different parts that you need for each one, there's a little estimate, gives you an idea of, you know, what the commitment is. The other project, one of the other no-code project is the LED maracas. So the LED maracas use a magnetic field. You can kind of see the loops inside the clear maracas. These are actually the same charging loops that are used for like charging phones, for wireless charging and things like that. And then the LEDs basically pick up the magnetic field from the loops and then turn on. So you can make these maracas that where the lights are inside, not wired to anything, and light up. There's a couple of different options for handle designs. But so this looks like it could be a fun one. You can 3D print handles, or there's like a design that uses like cardboard tubes and whatever. So these are the coils. This is how they come. And then you just have to basically solder on the wires. You shrink wrap the shrink tube the LEDs. This just keeps them from getting beat up when they're banging around on the inside of the maracas, and then assemble the handles. So this is an example of the 3D printed handle, which hides the magnetic loop. But the 3D printed ones, unless you print them very, very carefully, probably aren't going to come out as transparent as the clear plastic baubles that you can see here, right? If you printed them very slowly and polished them up, you could probably get them pretty clear, but they're still going to be a little bit more like translucent than really clear. But you get an integrated handle for holding the battery pack. So, you know, pros and cons. So the two projects that we have that allow for coding, the first one is, oops, I forgot to change the name of part of that one. This one's a Dragon Puppet. What's interesting about this project is not the puppet part at all. This was done with a $20 puppet off of Amazon. You could use whatever puppet you wanted. It's actually the light effect. So this one, it creates a waterfall of lights that run the length of the dragon using NeoPixels, which are an RGB lighting platform. It's compatible with Arduino and other microcontrollers. This is by far the most expensive project on the list, because the NeoPixels are quite expensive if you have to buy a whole roll. So the circuit itself is actually pretty straightforward. You have the microcontroller board, you wire it up to a battery, and then the end of the NeoPixels gets soldered to the microcontroller. And then you just program the microcontroller to run the lights.
Oh, sick.
Then, you know, so like one of the cool things I think about the two coding projects is that you can do exactly what's in the project, right? But then you can hack with it and do a lot of other things. So these microcontrollers, in addition to having the controls for the lights, they also have servo controllers. They also have speakers and microphones. So you can add sound effects, you could do a lot of different things with them. The only other thing I want to mention about the NeoPixels, so you don't have to buy a whole roll of NeoPixels. The Dragon Puppet, I think, requires like 3 feet of NeoPixels, and I think you can get that for 15 bucks. But if you don't buy a whole roll, what they end up doing is they take these rolls and they just cut them down, which means the piece that you get might be out of the middle somewhere and doesn't have any connectors. So if you get one piece out of the middle, then you're going to have to solder on your own connectors, which isn't that difficult. There's essentially spacing in each, all along this for connecting your own interface.
This is something we could do like with you on a facilitator hour.
Sure, but you'll want to buy the connector you want. But it's a good way to save some money. Like if you don't want to spend $100 on NeoPixels, but you want to do a project that involves NeoPixels. The other thing I will say is NeoPixels are kind of addictive. So once you've done a project with NeoPixels, you will probably come up with a bunch of other projects that come up with NeoPixels. So like $100 investment in NeoPixels will probably get used. But the important bit is just understand that you don't have to buy a whole roll. But if you don't buy a whole roll, then you get this extra project you're going to have to do to solder the connectors on. The other thing to mention on both of the coding projects is because these are microprocessors, they are somewhat static sensitive. So if you are not careful handling these, and I don't mean like computer in the 80s careful, like with the wrist straps and all the things, because a lot of times you're attaching this to like clothing and whatever, but like every once in a while, one of these things does get fried. So if it's really important to you that this project, you might want to buy 2. Because that way, if you fry one, you have a spare. That's not my advice. That's Iris's advice. And Iris knows a lot more about electronics than I do.
I have 2 questions.
Sure.
One of them, if it fries, it's inside a puppet, which is fabric. Is there a chance of, or is this just like in some sort of container?
Well, so this board here, right, has a bunch of different components on it, right? And usually what happens is one of these is I think it's an ESP32 microprocessor. Usually that's the component that got fried.
So not something that would set the puppet on fire?
No.
Okay.
No. I mean, it is possible to overheat these things. Like if you create a short in these, then they can get hot. But this type of circuit, like when you're prototyping it, before you sew it into the garment, you want to like run it for a while on the bench and make sure that it's not overheating anywhere.
Gotcha.
But for this sort of thing where you have relatively few connections and it's pretty straightforward, you're probably going to know right away if you've got a short somewhere. But if you've got, a bunch of different, like if you were doing the Arduino version of this project, where you've got an Arduino and you've got a separate board on top of that, and all of that's connecting to another IO board, and you've got wires everywhere, and you've done a bunch of different soldering of components, now maybe you've got a bigger chance that you've got some hidden short somewhere. So my wife was doing one that had this thing where that had like 2 little feather boards, they're called, that went next to each other. And if you reverse the feather boards, it created a short that fried the whole thing.
Nice.
Yeah, we figured that out after we fried them.
Oh no.
And it was smoking, like it was pretty bad. So that's why we test things on the bench. But the bigger thing is just that sometimes the microcontrollers will spontaneously quit working.
Gotcha.
We have an Arduino downstairs that no longer takes programs. I don't know why, it just doesn't. Could be the flash is worn out, could be that it got an electrostatic discharge. Who knows? Could be that the firmware is too old and it just doesn't want to talk to anybody anymore. But so these cost like 20 bucks,
Okay.
20 or 30 bucks. So, and like I said, control LEDs, control servos, can do a lot of different things. So having a spare one floating around in your, parts bin is not bad.
Cool.
This is the make code kind of like graphical programming interface. If you've ever seen like Scratch, this is very similar to the way that looks. This kind of saves you like the syntax of code. You're essentially taking these blocks and dragging them around to do your program. I think MakeCode is actually owned by Microsoft, but you can basically do all of your programming here and then write it onto the microcontroller, and it will just do the thing. The other programmable project we have is the Flappy Bat, which I thought was a great option for Halloween, but you probably won't have it done in the next 3 days. So, oh well. But one of the things that I liked about the 3D printed bat is that it has servo controlled wings. So flashing lights are a great thing for any microcontroller project, but servos are really the other piece that's, you know, kind of where it's at. So if you want to build robots, you want anything that, you know, can control itself, you're going to end up using these servo motors. Well, those Circuit Playground Express all have integrated servo controllers, which is one of the things that I think puts them above the Arduino suite of microcontrollers, because most of them you have to use a separate servo controller board. It's hard to drive servos directly from Arduinos because of the power limitations on the boards.
Right.
So in this one, you connect the servos to the microcontroller, 3D print the bat. Wouldn't have to be a bat. You could 3D print whatever you want. Probably
T-Rex and stumpy arms.
Sure. I mean, you know, but like, you know, try and match the whole pattern. Like this is the thing, is like the sky's the limit, right?
Yeah.
And then the coding for this is done in what's called Circuit Python. So Circuit Python is based on the Python scripting / programming language, and it allows you sort of a more native programming interface to the platform rather than sort of the graphical interface that MakeCode has.
So like lines of code versus
Right.
the
Right.
diagrams.
Right. And with Circuit Python, you also have the option of bringing in like any compatible Python libraries.
Oh,
Right,
there's
so,
Python
like,
associated.
oh, yeah, yeah. Essentially, there's a Python library for running, you know, the microcontroller board, and then this is just layered on to Python, right? So like if you had a Python library that you needed for, you know, a scientific instrument or something, you could use that in Circuit Python along with the rest of your microcontroller. I don't know that it would be too great at like AI, because the processors are pretty small, but you know, you might be able to do something. So with the projects that we've chosen, you know, this year, there isn't as much work to do in prototyping because most of the circuitry is going directly onto the control boards. But I do think it is important to make sure that you test everything like on the bench. So, you know, like with the stick figure, you know, even if you're gonna do that one, you know, attach everything before you start sewing it to the fabric, because you don't want to find out once you've got all sewn together that there's a problem. You want to kind of take everything in easy steps as you go. So we also have a section here on Tinkercad and really exploring some of the simulation techniques that are available in Tinkercad. So once you have a model in Tinkercad, if you look, this looks a lot like the MakeCode.
Mm-hmm.
So you can actually use these things together and even do your programming right in Tinkercad, as long as the components that you're using are compatible. So Tinkercad, I know, supports Arduino. Some of the newer microcontrollers from Adafruit, I'm not sure if they're supported by Tinkercad, but I would expect they would be, because Tinkercad is, you know, a very popular platform. But as you can see, you can just create your wiring up in Tinkercad, and then you can simulate what's going to happen. It'll do the same thing with lights and other things too. So as I mentioned before, like try and make sure that you test, you know, sort of, you know, all through the process of your construction, right? So like if you had to solder new connections onto your NeoPixels, you know, solder the connections on the NeoPixels and then test that before you try integrating them with the rest of your module. test everything as you went. So like when you were doing your soldering for your bug for the second one, like we tested every component you soldered as you added it on, because we didn't want to get to the end and then find out there were 3 problems.
Did it work?
Yeah.
Oh, nice. That's awesome.
It was gorgeous. It was flawless. Like I wish mine looked like that. No, it looked really great.
Nice, nice.
But so, like I said, because this time we don't have as much of that sort of designing our own circuits, you probably won't have as much application for a breadboard. But I would mention, when you look at these microcontrollers, a lot of these projects have you soldering directly to the board. There are alternative, construction methodologies for this. You can solder connectors onto the board and then connect all of these things to the connectors instead.
Pins.
Yeah.
And if you want pins, the company I work for makes them.
What?
Nice.
Crib pins and stuff like that.
Yeah. Nice.
Good plugin right there.
Yeah, we probably have bins and bins of the stuff downstairs too, but like, but there's probably like, you go through them. So like a lot of these projects, you'll get like a pin header and they'll be like, well, you only need 3. So go down 3 and then clip it off. And then it breaks diagonally and you're like, great. So then you have to go down 3 and clip it again. But, if you want to have modular circuits, right, then you would, instead of soldering all these things directly to the boards, you would solder connectors on. And that makes it easier to repurpose these things later on for other projects. So like on Halloween, you want a flappy bed, but in Christmas, you're going to swap it out for a reindeer or whatever. You might want to.
That's 4 movable legs. Going from 2 servos to 4 servos.
Right. Or, 2 servos that have some sort of mechanical connection that drives 4 legs.
No.
I think
Yeah.
I'm picking up what you're putting down.
Yeah.
Sounds sick.
So, and then the other thing I'll say, because I've heard that some people were not incredibly impressed with the project options that we have. If you decide that you want to do something else that's outside of these 4 projects, there are hundreds, if not thousands, of projects on adafruit.com and on other websites. And many of them are at a similar level of difficulty and well attainable by anybody with the capabilities that that you all have at this point. So if you want to do something else, I'm okay with that, and I will happily help you with it. But if it involves like this much electronics, you're not going to get it done in 2 weeks. But the other thing I wanted to show, because I had shared this with Unit previously, but no one else, I've attached this slide to the end of every previous slide deck now, but this is the first time I've managed to finally remember to get to it in class. This is actually my home soldering setup, which looks a lot like the soldering setup here, because mostly I ordered all the parts that Iris orders for the soldering classes here. This is my dining room table. And everything fits in that blue bin except for the light. You're gonna get these slides.
They're on stuff.
But
It's just better this way, trust me.
yeah, but basically, really all you really need is the soldering iron and solder, and the rest of it is just like, kind of like when you need them. So kind of add them as you need them. The desoldering, the pump and the braid both work for kind of different things. So I like having both. The flush cutter, any sort of cutters will work, but those flush cutters cost like $5, so what the heck. The tip cleaner is really important. There's like 2,000 different kinds out there. They all basically have like a brass Brillo pad in them. Any of them are fine. Like this is a cheap, like brass painted plastic one. Like, there's a fancy Weller one, but it doesn't matter. I bought the little tool bender. It's like $7, but you know, you can bend the things by hand. But I do like the silicone soldering mat. Because when I was doing this at my dining room table without the soldering mat, dripping solder on my dining table, I felt kind of bad about it. Not terrible because I'm not the only person that does projects at our dining table. But also it made it a lot easier to find parts when they fell down. One, because they show up better against the soldering mat, and also they don't bounce as far. So the soldering mat is nice.
Oh, yeah.
Some of them have like ESD connections, like if you want to have electrostatic discharge with strap and whatever, you can do that. I needed the light, so I got like a $20 ring lamp on Amazon. That was like a big win for me because I can't see because I'm old now. And then I don't have a fume extractor, which isn't a bad idea to get, but I don't use any lead-based solder, so I'm just burning rosin.
Just tin and rosin.
You should probably get one, but like it would almost have doubled the cost of my setup to have a fume extractor.
Oh,
So
it's
some-
as expensive as everything else combined.
Well, so I think the most expensive thing is the soldering station. They cost for a good one like over $100.
Okay,
The rest of it is all like $10 and $15.
interesting.
They add up when you need to buy all of them, but like
Yeah,
but the fume extractors are like $100.
makes sense. Yeah.
So like that's the single biggest thing. Like my kid really wants one because he, for some reason, when I'm soldering, like the fumes seem to go somewhere else. But when he's soldering, they all go right in his face. So I don't want to get a fume extractor eventually.
You have a,
Oh, it's awesome to see your setup.
Yeah.
so a box fan you can set at the end of the table.
Yeah, or
The air
something, you know,
movement.
like, but it's so funny because like I'm watching the stream of smoke just go, but like right.
Straight into the lungs.
But anyway, I wanted to share that just because this is not, you don't have to have like a lab to do this stuff. Like all of this stuff goes in that bin and it goes in with a bunch of other bins that live for other projects in our house. And it takes me like 15 minutes to set up and 15 minutes to put away. And so whenever I feel like soldering something, I solder.
Is this, I will reveal my ignorance, basically the setup downstairs is,
Very similar.
these the
So,
same parts?
pretty much. So like we have mostly the same tools in the class that we have downstairs. The exception is, I don't think we have the same stands downstairs that we have up here. So this stand is the AVEN stand. The stand I think that we have downstairs is the Weller stand that has the 4 alligator clips on it. And depending on what you're working on, you may want that stand, but this one is more rigid when you're working on circuit boards. When you are doing, if you're doing just like loose wires, or you have a weird part that isn't squared, you might want the other kind. So I actually have both, but I always use this one first because this one is more solid. We don't have the silicon mats downstairs. We have some sort of gnarly thing, anti-static mat taped down that's full of burn holes. But otherwise it's pretty much all the same. Once you get into like advanced soldering, so like if you want to do surface mount soldering, you would need to have some additional tools. So you would need to have like some tweezers, you need to have a magnifier. The solder that you use is smaller than this solder, and you generally use a separate flux. There's a really great surface mount soldering class that Iris runs for the bike spoke lights. Really great, highly recommend it. That's how I learned it. But you can do tons and tons of really fun through-hole projects right at your dining table. Like I've done surface mount soldering, you know, with this setup. I just have my magnifier and all the rest of the surface mount stuff is in the bin. And that's it.
Awesome. Thank you.
Thank you.
Yeah,
Have a great week.
So the electrical bench, is that next to the radio?
Yes.
Okay.
So
They're like the big industrial blue metal tables covered in weird stuff.
Okay, I'm gonna go down there to.
I know, I never really noticed.
I think it
it.
is.